So we're going to be starting our probability unit, and a lot of the stuff we do at the beginning of the unit is going to seem familiar to those of you who took Algebra 2 with me or with another teacher and you did probability in that unit, but it is going to get more complicated as we go through the unit. So we're going to start with some review, and then we'll ramp up the difficulty and the level of sophistication of some of the questions that we're going to see as we go on. But basically, probability is always just asking one simple question. What is the number of desired outcomes? And how is that number compared to the number of possible outcomes? So usually we say that if we're asking for the probability of some event E could be anything, but in this case we'll just let E be some general event, then that's going to be equal to the number of desired outcomes divided by the total number of possible outcomes. So what we're going to do is go through some very simple examples of probabilities that we can calculate just to get warmed up and started in this probability unit. And what we have here are 10 stick figure people that have some different traits. So we're going to ask for some simple probabilities related to these 10 people. For example, let's say I wanted to know the probability of selecting a person in this group who has a red hat. And I'll just say probability of R, meaning probability of a red hat. Well, if I use this simple probability formula, I want the number of desired outcomes to be in my numerator. And so in this situation, that's just how many people here have a red hat. And it looks like of the group, I've got one person here with a red hat, another person here with a red hat. So 2 total people have red hats in this group. But I have to divide that by the number of possible outcomes. And so what I mean by that in this situation is how many people are here in total who could have had red hats. And of this whole group, I've got 1, 2, 3, 4, 5. I have 10 people. So of the 10 total people, 2 of them have red hats. So this is one way to represent that answer, but usually we reduce these fractions. So this would be one great way to represent the probability of selecting a person at random from this group who's wearing a red hat. Also, I could write this as a decimal. That would be fine. Or I could have written this as a percent. Also totally correct. So as long as you're not rounding, you can write them in each of these forms, but a fraction is the safest form, although we are going to use percentages and decimals regularly as well. What if we were looking for the probability that someone from this group is wearing a green dress? So again, that's the number of desired outcomes. How many people here have a green dress? 3 of them have a green dress. And what is the total number of possible outcomes? Well, there were 10 total people here, so that's 3/10. Can't reduce that at all, but I could write that as 0.3 or as 30%. So all of these would be correct answers. How about the probability, and I'd encourage you to just pause the video and do these on your own, that someone has blue shoes on? Okay, again, the number of desired outcomes is the thing that goes in the numerator, and there are 4 people here who have blue shoes out of a total of 10 people. And so I would rather present that as 2/5 or as 40% or 0.4. All right, so let's just get a little bit more complicated with my language here. What is the probability that I select a person at random from this group who is wearing a green dress and a red hat? So we're going to get more into specific representation of how to write something like that, but for now I'm going to write probability of green dress and red hat like this. Hopefully many of you know the better way to write this. We'll talk about that in our next lesson. So the question is, how many people here have a green dress and a red hat? Well, I'm just going to start by looking at green dress people because I know that it's got to be at most 3. Okay, so green dress but no red hat, that person doesn't count. Green dress, no red hat, that person doesn't count. Green dress and a red hat. So there's only one person here out of the 10 total people who meet the criteria of having a green dress and a red hat. And so that could be written as 0.1 or as 10%. Again, I could say, what's the probability of selecting a person at random here who has blue shoes and a red hat? And in that case, it would be the same, right? Because I only have one person here who has blue shoes and a red hat. But now I'm going to change up my phrasing, and I'm going to say, what's the probability of selecting someone who has blue shoes or a red hat? The difference between and or is a big one. And means I can only count people who have both this trait and this trait. Or is much more broad. Or says I can count people with blue shoes and I can count people with red hats. They don't have to be happening simultaneously. These are things we're going to get into more in our next lesson, and hopefully they are review and things that you remember from Algebra 2. But let's take a look at who meets this criteria. So what is the number of desired outcomes here? Well, in this case, because we're using or, anyone who has blue shoes or has a red hat counts. So this person does not count. They don't have either of those. This person does count, so that's one. They have both, but that doesn't matter. They just have to have one or the other. This person has none. This person has the blue shoes, so they count. They have none. This person has the red hat, so they count. Nothing. Blue shoes, they count. Nothing. Blue shoes, they count. So I counted 5 people there who had one of those traits that I was looking for. And that's out of the 10 total people who are here, which actually ends up being 1/2, which I could write as 0.5 or 50%. So those are just some examples of some basic probabilities that we are going to get into some more complicated things throughout the rest of this unit, but just some basic ones to get us started. So what I'm going to do is go through some more examples on the next page. I want you to really try to do these on your own, though. So in this case, we've got a bag of marbles. You're going to have to count up how many marbles are in this bag if you're going to try doing these on your own. But I'm going to ask a few simple questions. What is the probability of selecting a yellow marble from this bag? What's the probability of selecting a blue marble from this bag? What's the probability of selecting a white marble from the bag, a red marble from the bag, or a green marble from the bag? And then I want to know, what's the probability of selecting a marble that is not yellow? And what's the probability of selecting a marble that is blue or green? Pause the video and try to answer these questions, and then I'm going to quickly run through the solutions here. All right, let's talk about the answer. So you should have counted 20 marbles. There are 20 marbles in this bag, and so our denominator in these cases is going to be 20. If I know there are 20 total marbles, then in every case, my number of possible outcomes is 20. Some of these fractions might be reduced, but we're going to start off with a denominator of 20. And so, how many yellow marbles are in this bag? Well, there are 3. You can't reduce that. So we're going to write our answer as 3/20. If you just write it as a decimal or as a percent, that would be totally fine as well. Blue marbles, let's count them. 1, 2, 3, 4, 5, 6 blue marbles. So 6 out of 20 or 3/10. Again, a decimal or a percent would be fine there. White marbles, there were only 2, but we would want to represent that as 1/10 or as 0.1 or 10%. Red marbles, there were 4, so I would want to represent that as 1/5 or as 0.2 or 20%. And then green marbles, we had 5. So I would want to represent that as 1/4 or as 25% or 0.25. Now, what's the probability of selecting a marble that is not yellow? So in that case, I'm going to count up every marble that isn't yellow. This one counts, that one does not. This one counts, and obviously, hopefully you're recognizing there's a faster way to do this. If I'm just going to count all the marbles that aren't yellow, let's just look at how many marbles were yellow and subtract that from the total. So if there are 3 marbles that are yellow, there obviously must be 17 marbles that are not. And this is called the complement of a set. Meaning everything not in a given set. And it's a term that we'll use a little bit later on in this unit. Finally, what's the probability of selecting a marble from this bag that is blue or is green? So any marble that is blue counts, and any marble that is green counts in this category. And it looks like there were 6 blue marbles, and there were 5 green marbles. So it looks like there are 11 marbles in this bag that are either blue or green, and you can't reduce that fraction either. So on Tuesday, we're going to have another lesson where we're going to get into a little more specifics, especially on these or and statements. But for now, hopefully that's just a simple review of basic probability, and that should be enough to get us started moving forward.